Okay, it is Wednesday, May 13th, 2020. We're in Advanced Math, Trig, mods 2, 3, 4, and 7. We're going to continue on with a more specific look at certain functions from our library of functions that you guys need to carry forward with you into next year. We've already looked at linear and quadratic. Next on that list on your library of functions, if you have that out as a reference sheet and are looking at all the different types of functions, you've got to be able to graph quickly and accurately by hand. Again, no calculators today. When you submit your assignment to me, I need to see a little bit of work showing that you followed the procedure I'm quickly outlining to create and sketch the picture you came up with. We're not typing them into a calculator and copying off the screen onto our paper. That's not what this is for. One note, if you look at that library sheet, the next function we were supposed to graph was a cubic function, y equals x to the third. So for example, I could have on this paper, y equals 2x cubed minus 7x squared plus 5x plus 10, and say, here, graph that real quick. Okay, those are the polynomial functions, if they're third degree or fourth degree, that you're not going to have to graph by hand on the non-calculator part in calculus, because there's so many steps involved. If you remember the P over Q list, synthetic division, finding your roots, and drawing roller coasters that go up, down, up again. If it's a fourth degree, it might look like a W. Those will be calculator driven on the part of the calculus next year. So we're not graphing those by hand. So they're eliminated, skipped, and that's why today we're on to radical functions, whether it be a square root box, which of course is a radical sign, or a cube root box, which of course is also a radical sign. So these all fall under the words radical functions. Okay, on your mental library. That's why that sheet is so important. As soon as you see a function with a square root box, you're thinking, remember, that half of a sideways parabola, correct? Remember the y equals radical x started on the origin and went like that? Okay, whereas when it was a cube root box, it started on the origin, did the same thing, looked very similar, but I think I described it as having a tail in the other direction. So if this is already in your mental library, you know what these are supposed to look like as you attack them, and you don't want to finish the question until it gets that similar shape. Okay? All right, here's my advice on all radical functions. Remember, our goal is, can I graph this as quick as possible and sketch it on my paper quickly and accurately. All right. How do you know where to begin on this problem when you make your... Now, notice I do have an XY table on all four of these. There's no shortcut like good old y equals mx plus b, or a vertex formula like negative b over 2a. There's not a shortcut, here, quickly let me do this approach. You're going to make a table, and you've only got to quickly supply 3 numbers on that table. Now, careful, if I said ready, set, go, everybody try this. Some of you might put negative 1, 0, and 1 in for your 3x coordinates. Well, immediately you would know that didn't make sense because what? What's the rule on a square root box? You're not allowed to plug in a negative number, are you? So your starting point is plugging in whatever number makes the radical box have a 0 underneath it. Okay, so you want to always, because that's going to be the initial point, that initial point that's so important to get your curve going. So whatever number turns the radical box into a 0 is the number you start with. Well, here, since that plus 2 is outside the box and it's irrelevant right now, obviously you agree that the number I would plug in to make the radical become a 0 is indeed 0. There's my start. You got to have a correct starting dot. You want to draw the whole function from beginning to end. And when I plug that in, the square root of 0 is 0. plus 2 gives me 2. And then the question becomes, well, how do I know what other numbers to plug in? Now, technically, I'm allowed to plug in any other 2 numbers I want to that aren't negative. So if I wanted to plug in 13 and then 57, you're allowed to. But of course, you're going to pick numbers that in your mind make sense because we're doing this quickly and accurately. Oh, so I would plug in 1 and now freeze. Some of you might say, oh, let's plug in 2. Well, no. Remember, I don't have there is not a calculator out on your desk right now. There's not one out on my desk. 2 would not be a smart, convenient number. Don't you want to pick a perfect square? So 0, 1, and 4 are the 3 numbers that would make perfect sense. When I take 1 and I go plug it in for x, the square root of 1 is 1. 1 plus 2 is 3. Then plug 4 in. I don't want to plug 2 in and get the square root of 2, which is some decimal. And again, I don't have a calculator. I'm trying to be as accurate as I can here. So if I plug 4 in, perfect squares are what you want to pick. The square root of 4 would be 2 plus 2 gives me 4. Oh, so now I know. Notice I never put any marks on this until I see the numbers I'm going to work with and plot. I'm going to go 4 in each direction because that's the biggest number I see on my table. Now, not that any negatives are needed, but if I plot these 3 points, 0, 2 is my initial point. Got to be there. 1, 3 would be right 1 and up 3. And by the way, the reason you're not allowed to only have 2 points, that looks like a line, doesn't it? Every time you only have 2 points, it looks like a line. To see the exact curvature of your picture, we always need a third point to confirm what's going on. My third point is 4, 4, so I go right 4 and up 4. It's way over here, and I did indeed create that curved shape we were seeking. Okay? All right. Now again, if we were in calculus, I could say, what's the slope of this curve right there at that point? Oh, remember, to find the slope of a curve at a point, we would take the derivative of that function, wouldn't we? And it's going uphill, so we get a positive answer. If I went from 0 to 4 and colored in all the area, I could integrate that function from 0 to 4 and plug in my numbers and find my area, things like that. I could actually rotate this and spin it around the x-axis, make a 3-dimensional shape, and eventually next year find its volume. But again, you got to know how to sketch it accurately if you're going to answer any questions like that. All right, number 2, again, is a radical function. Your brain is thinking, on a radical function, I want to turn the radical box into a 0. Okay, now careful. Notice I didn't say start by plugging in 0. I never said that. You want to create a 0 under the radical box. So guys, look, I think it's pretty obvious you'd plug in a 2, wouldn't you? Because 2 minus 2 gives you the 0 under the box you were seeking. So this time we're actually starting with a 2. 2 minus 2 is 0. The square root of 0 is 0. Plus 1 gives me 1. And then you go from there. I need 2 more numbers. I'm thinking 3 is the next best choice. You got to use your brain on these. You got to be a thinker. Don't just copy and not think with me here. Why did I pick 3? Isn't 3 going to create that next perfect square we're seeking? What's 3 minus 2? 1. The square root of 1 is 1. There's a negative in front of that 1. So negative 1 plus 1 gives me 0. Now, guys, 2, 3, don't plug 4 in next. And you go, well, why not? Because 4 minus 2 is 2, and I don't know what the square root of 2 is. Remember, I don't have a calculator right now. I'm going to plug in 6, right? Because what's 6 minus 2? 4. The square root of 4 is 2. Negative 2 plus 1 is negative 1. So my 3 points to plot, I do have to go right 6, obviously, and then I'll go up a few, left a few, and down a few. 2, 1 is there. 3, 0 is there. Right 6, down 1 is there, and I end up still making a curve that looks half of a sideways parabola, right? That kind of looks like a parabola that's sideways, but it's the bottom half. Oh, because there was a negative in front of there, giving you the bottom half instead of the top half like that. Okay? All right. Third one. 2 more and we're done. I got y equals 2 plus the cube root of x. Okay, this is a cube root box. I'm going to give you the same advice. We want to start by making the radical box become a 0. So we're going to start by plugging in 0, because the cube root of 0 is 0, plus 2 is 2. Now careful. Remember, a cube root function looks like the same curve we just sketched, right? But wherever that dot's at, it has a tail that's a bottom half in the other direction. So if we've just located that important dot by making the radical turn into a 0, wouldn't we pick one number to the right of that point and a number to the left to have it curving in the right direction? So if 0 was the location of our important first dot, give me a number to the right of 0 that would make sense in here, and I would say 1, because isn't that a perfect cube root? What's the cube root of 1? 1 plus 2 gives me 3. Now let's go to the other side of that initial point we created. If the initial point again was 0, 2, 0 is my important dot. I picked a number to the right of it, 1. Now I want to pick a perfect cube to the left of it, which would be -1. Remember, you're allowed to have a negative number under a cube root box, correct? If I took -1 and plugged it in, what's the cube root of -1? Oh, it would be -1 plus 2 gives me 1. So picture-wise, again, I don't need a ton of room here. I'm going to go 3 in each direction. 0, 2 is right there. That's my initial important dot right in the middle. Right 1 and up 3. Oh, is the dot that allows my curve to go this way. If you have any doubt, the next number you would plug in would actually be 8, wouldn't it? Right? Because the cube root of 8 would be 2, plus 2 would be 4. I'd go right 8 and up 4, and my next dot would be way over there. And then when I plot left 1 and up 1, oh, that makes sense. The other number to confirm that I'm going this direction would be -8. The cube root of -8 would be -2 plus 2 would be 0. So it eventually does cross the x-axis. It's just not going to happen for quite a while. And you've got your sketch, the shape we were seeking. We know that's what it looks like because of our mental library of functions from day 1. All right, finally, last one, kind of our grand finale on radical functions. Again, I'm ignoring everything and focused on the cube root box. I'll give you a second here. What number would you plug in first on this XY table? Wouldn't it be -3? Why'd I pick -3? Because that's the number that creates a 0 under the radical box. So -3 plus 3 is 0. The cube root of 0 is 0. 0 times 2 is still 0. Minus 1 gives me -1. Now what number should I plug in? If I went to the right of -3, right, you got to think, wouldn't I pick -2? Because think about it, -2 when plugged in is going to create the next perfect cube I was seeking. Plug -2 in for x. What's -2 plus 3? That's 1. The cube root of 1 is 1. 1 times 2 is 2, minus 1 is 1. Now, if you're confused as to what number I should plug in next, remember, you can always go and plot these right now. You've got enough to work with. It looks like my initial dot is what? Left 3 and down 1. And this one here was left 2 and up 1. So I've got this going on. I need a tail on the other side, don't I? Because we've envisioned the picture we're supposed to sketch. So it's pretty obvious to the left, -4 is the next number I would go plug in. Negative 4 plus 3 would be negative 1. The cube root of negative 1 is what? Negative 1 times 2 is negative 2 minus 1 is negative 3. I'll be darned. So for my third and final dot, I'm going to plot the point left 4 and down 3. And this thing's going to have a tail going that way. And my curve looks like that. So a cube root function takes on that shape. A square root function takes on this shape. We already knew that heading in. Okay? Now, I did a lot of thinking and explaining. Hopefully, when you get comfortable with these, man, you should be able to zip through and do them as quick as possible with the goal of giving me an accurate sketch to then attack whatever calculus question that comes. Okay? All right, great job. Your homework is these 4 right here. So if you want to hit pause at this point, they closely mimic what I just did. Your job is to make a table, pick 3 correct points, think your way through 1 dot at a time, sketch a graph that's accurate. This is, again, an 8-point daily assignment. You get a point for using and showing me the right process, and then a point if you end up doing it right and getting the picture to turn out okay. So it's like a little 8-point daily quiz that you're going to turn into me. Well, since today's Wednesday the 13th, these 4 problems you're looking at would be due, what, Thursday the 14th by noon. Stick with our routine and keep rolling day by day. We're getting there. We're going to keep sketching these functions through next Thursday, and then wrap things up next Friday the 22nd. Okay, so hang in there and keep working, and appreciate your time. We'll see you tomorrow.